All right, honors geometry. So we're going to start looking at some proofs. Okay, these are not simple. It takes a certain mindset to do proofs. I'll try my best to walk you through them. But again, hopefully, you get this idea of this deductive reasoning, this logical reasoning, and you can work through them. All right, so this first proof says, given segment AC is congruent to segment BD, prove that segment AB is congruent to segment CD, okay? So notice what they started with. They started with the given. Segment AC is congruent to BD, that's given, all right? So notice AC and BD have some overlap. They overlap on segment BD or BC, okay? So again, let me get my pen and show you what I mean. So here, let's use red. Here is segment AC, and here is segment BD. So notice they both have this, I'll do it purple, right? If we know our colors, right? Red and blue make purple. So there's our overlapping region. Well, what happens if we take that overlapping region apart or away? Well, you'll have AB and CD left. Well, isn't that what you want to prove? Don't you want to prove that segment AB is congruent to segment CD? So think about this. If you take two larger segments that are congruent and you subtract the same segment length away from both of them, aren't the remaining pieces going to be congruent? Yes, that's true. All right, so that's the proof here, right? So I always like to think it out as far as I can before I actually do it. So the first thing I want to write down is I want to say that BC is congruent to BC. So if you say type a statement, notice there's all these choices. Well, we're going to type that the segments are congruent, right? And we're going to say that BC is congruent to itself. Now, we talked about this is a new property called the reflexive property. And you try it, and boom, it's good. So now, with AC and BC, if I take AC and I take away BC, I'm left with AB. Same thing over here. If I take BD and take away BC, I'm left with CD. That is what I want to prove. So I want to prove that segment AB is congruent to segment CD. And the reason here is a version of the segment addition postulate. So if you look through here, okay, it's this idea of congruent segments. Now, congruent segments added to congruent segments form congruent segments. We didn't add. We took the larger segment and we subtracted that common area of BC. So congruent segments subtracted from congruent segments form congruent segments. Again, it's a version of the segment addition postulate. So we're just trying to get you familiar with proofs. So again, just bear with us. And that's what I want to prove. Notice the green check mark, submit my answer. Yes, I do want to submit this. And boom, I'm right. Now, sometimes your way of doing it is not the same way they do it. So you can take a look at what they did by using the next button. But in this case, their way was the exact same way as our way. And there's the 2-column proof down below. Awesome. All right, I got one more on this video. Okay, so in this problem, so we are given that angle ADB is congruent to angle CDB, and you want to prove that triangle ADB is a right triangle. So let's do some marking real fast. So I like to mark congruence. So remember to mark angles congruent, use an arc. So ADB, that's this angle, mark it congruent. Okay, and then CDB. That's this angle, we'll mark it congruent, okay? And we are very interested in proving that this triangle, ADB, so this one right here, prove that this triangle is a right triangle. So of course, the idea is to show that that is a right angle, all right? Well, think about this. These two angles down here, ADB and CDB, don't they help make this straight line or segment AC, right? So if you look at this picture, this is a linear pair, angle 1 and angle 2. They form a linear pair. So they're going to be supplementary, right? Because linear pairs are supplementary. But they're also congruent. So think about that. What two angle measures that have to be the same would be supplementary or add up to 180? Well, they have to each be 90 and 90. And what does that make each of those angles? Right angles. And what does that make each of those triangles? Right triangles. Boom. The proof is done. Just talked it all out loud. Now it's time to write it all down. And you're like, what the heck did he just say? I have no idea. Well, I mean, I'm thinking 5 steps ahead. It's a lot, but as you get better at proofs, you think ahead. It's like chess, right? You got to think moves ahead. Okay? All right. So let's take a look here. So again, ADB and CDB are also supplementary. So I'm gonna state that right here. Angles are complementary or supplementary. Angle ADB and angle CDB are supplementary. And again, why did I want to say that? Well, I get the number 180 involved, right? 180 will help me get 90. What is that reason? If two angles form a linear pair, then they are supplementary. Boom. All right, good. So now, because they're congruent and because they're supplementary, each of them must be 90, each of them must be a right angle. Since angle ADB is in triangle ADB, let's say that angle ADB is the right angle right here. Angle ADB is a right angle. And let's see what the reasons could be. So no, angles which are supplementary and congruent are right angles. So that's an idea. Try it. There you go. And now that angle ADB is a right angle, that means that this triangle is a right triangle. Not angle, sorry, triangle, sorry. Classified triangle, here we go. So triangle ADB is a right triangle. And again, I haven't said this, but notice that the reason is not prove, the reason is why, right? And that is the triangle contains a right angle. So it's not the word prove like it is the word given up here. It's some sort of a reason. We try that. Boom, green check mark. I can submit. Yes, green check mark. And again, if you look at their steps, same exact steps as ours. Great. Okay, 2 down. I got 2 more to go.